Hey everyone, it is May 19th, 2020, time's about 12:15 CDT. It's 66 degrees Fahrenheit out, and it is Geo-Rant time number 124. I was going to do a part 3 on metamorphism. I was going to talk about retrograde metamorphism, but I decided not to do that. I actually kind of was pulling back when I did parts 1 and 2, which is Geo-Rant 122 and 123. Parts 1 and 2. I was kind of getting to it, but I didn't want to cross that line because it would have made it erroneously long. But anyway, what is this about? Well, I'm going to talk a little bit today about rocks up north. Generally, as you head up from the coastal plain, Gulf of Mexico, the Florida Panhandle, come up through Georgia, up through Tennessee, Kentucky, Illinois, Wisconsin, the UP, and Ontario, as you go from south to north, the rocks progressively get older. Okay, North America was built from Canada on. We have a lot of accretionary terrain, stuff like that. These are talks for another time. I'm not going to get into those right now. We have like a dozen orogenic events over the past 3 billion years alone. But anyway, what am I talking about today? Well, Sarah and I, probably not this year. Next year we're going to Greenland, so it's not going to happen next year. But we plan on going to Pickle Lake, Ontario. This little town is as far north as you can drive on a non-seasonal road into Ontario. It's Ontario Route 599, and it goes from near Thunder Bay up and up and up. And why are we stopping there? Well, obviously there'll be a roadside book out of this. But, the distance from Thunder Bay to Pickle Lake is the exact same as it is from northwest Indiana, where I live, to the Keweenaw, where the cabin is in the UP. Like Houghton, Hancock, north of that even, between there and Copper Harbor, just around a town called Calumet. So it's like that drive again. Why are we doing this? Well, because it looks awesome for one, and because of that general trend, rocks getting older. Now, I often will take map excerpts. I have, for provinces and states that I study and do stuff in, I have them color-coded. In Ontario, unfortunately, I wasn't thinking at the time, got stuck with the short stick and got the pink color. It's probably the second most abundant color I have in my library. Michigan is orange, which would probably be number 1. Number 3 would be yellow, which is Illinois. Number 4 is probably Wisconsin, which is green. So yeah, but anyway, as you can see here, this is a specific Ontario geologic map that I'm referencing here, and I took excerpts from it, and it's in color so I can read it without having to pay for a big, huge, because geomaps are usually generally big. They're like, we're talking like a meter by a meter sometimes, okay? So these are PDFs, so I copy, I screenshot, then I paste into Publisher, and I make a PDF from that. But anyway, this is the general area we're looking at here. So you can see down here, that's basically where here's Lake Superior. You can't even see the cabin. The cabin is south of this even, and it's this map area, but Pickle Lake's north of this more. So it's just like right here, and that's the map area. And there is something interesting there that I want to mention, and while we're there, obviously I'll do a recording and stuff. We're probably not going to be able to get to the actual spot because I think it's on an island in this Kishogama Lake, or Kashawigama Lake. So some of it's mapped a little outside of it, a little bit. It's a yellow, and a little place there I have my I don't have it on there. GPS coordinates. GPS coordinates 559 is over here. You can see it. Pickle Lake's still north of that. This rock, you Google, this is funny, you Google oldest rock in Ontario. What are the oldest, or whatever. Everything but Ontario comes up. Canada, yeah, I know the oldest rocks in Canada. I know where those are. It's not what I'm asking. I'm sure it's in there buried in some PDF somewhere or something. But I decided to actually look for myself. And I know, because of that general rule, that it's probably going to be up north more. Well, This one thing, as far as I could find, based off actual dating, this isn't based off relative dating and bracketing, saying, oh yeah, this super suite of igneous intrusions is probably between 3,600 million and 3,500 million years old. This is from actual dating, actual zircon dates. And what we have in this map area on the way up to Pickle Lake is the Kashiwagama suites, which are dated at about, so I got to actually look at it, 3285 million years old. Okay, but if you start researching Ontario and stuff, you'll start to see maps with older geologic ages further up north. So I decided to go a little deeper. I actually printed out the pinkish on this time, and there's two maps that I reference here. This one, which is a small scale map, and a more larger scale map. I think I said that right. More larger scale map showing the smaller area. If I can find the bloody thing. Which actually, yeah, this one, Yellow Lake. I think it's Yellow Lake. Yelling Lake, sorry. Yelling Lake area, which is within this map, okay? There are several zircons pulled from really up north in Ontario along the border with Manitoba. Let's see if I can get a zoomed out location map. I don't think there is one on these maps. But anyway, yeah, here we are. This is close enough. That Pickle Lake zircon that I told you about, or south of Pickle Lake, that we're going to stop at's down here. This one's all the way up here. It's up here. So if you start getting towards Hudson Bay and stuff, you actually start to get some Paleozoic cover, and I'm not interested in that stuff. So that's about as far north as you can get in the oldest rocks that I am aware of. But here's the thing. There's something interesting about there. You go up there. Okay, so I excerpted this, and I have, you know, this is that map, and then there's an A and a B zoomed in. And what you'll see here is you'll see a couple of dates. Like here, we have a date here, and you'll see 3292 inherited grains in tonalite. And then you'll see 2690 to 2711 granite dike. So what does that mean? What's an inherited zircon? Well, basically, it's a synonym for xenocryst zircon. Basically, what happens as you'll have, in this case, it's the trying to remember the name of the terrain. It's the Northern Superior Super Terrain. I'll say you just have an existing cratonic terrain. We'll say it's homogeneous for the sake of argument, and it's a granite. And we'll say that was deposited 4 billion years ago. Well, okay, tonalite, I guess, because there were really no true granites then. Plate tectonics was not in operation then, so I'm not going to talk about plate tectonics. We're still not sure what was going on, but time goes on. That supersuite was formed through a series of intrusions 4 billion years ago. And it just sits there and sits there. Then about 2,800 million years ago, 2.8 billion years ago, an orogenic event occurs and plutons start coming up in through that 4 billion year old suite. Well, as it comes up through, and since it's a magma, it will melt that existing rock and incorporate it into the magma as a melt. Well, zircons are pretty durable things. They will melt, but not so readily, and they can get incorporated into those new plutons, and they can also, well, that magma can also grab a bit of this original rock, the original old 4 billion year old rock, or the country rock. It can grab bits of the country rock and hold it in there and not melt that, and there'll be zircons in that as well. So it's inherited from that older rock, from that 4 billion year old country rock. Okay, that's what that means. But the actual age of the rocks, the actual age of the rocks are Neo-Archean. There's some Meso-Archean there, but no Paleo-Archean, except for in those inherited zircons. Which is odd because we've always thought that it was Paleo-Archean, or about 3.5 billion years old, a little more, or around there, plus or minus a couple 100 million. But it's not. It's a lot younger. Well, why is that? Well, if you look at the maps here, what you have here is you have a lot of superficial covered glacial stuff. Okay, here's the map, and this is just a rough bedrock map. But if you look at where these samples were taken, one's up here, another one's down here. You can see there's one defined pluton, and everything else is just generically mapped. There's no mapping detail. There probably is rock around there that is 3292 million years old, or 3209 million years old, and the other one. So about 3,200 million years old, or 3.2 billion years old, somewhere under that glacial stuff. It's not like it is out in the States, even in so-called isolated areas of the U.S., like the Pinocchian orogeny, which is about 1.85 billion years old, so significantly younger than this, but still Precambrian. We're in the Paleoproterozoic there, or in the Proterozoic, I should say. I don't know if it's exactly paleo off the top of my head. I forget. Sorry, brain fart. But anyway, what you have there is you have an orogeny. You had two continents colliding, and what you had is you have your original country rock, and then you have these little plutons. But we can map those. Why? Because it's populated. People dig. They put wells in, so you have good subsurface data that you don't get from, get further up northward. Literally, the population is 0. Okay? There are no towns up there. So you got to go off the limited outcrops you have. So these little plutons are probably all over the place, and the country rock is probably there too. It's just not exposed, or no one's found it, and it has not been dated. So I just wanted to go through that with you. I just wanted to cover what leads me to decide where we go. We're not going to go up to the northern tip of Ontario, or northwestern tip, I guess they call it too. We're never going to go up there. You have to fly in, you can't drive, but we will be going to Pickle Lake, and I will be visiting the area of that actually oldest dated rock that I know for sure in Ontario, which is that 3285 million year old. I think it's 3285. Yeah, 3285 million year old assemblage rock, and I believe, what is it? It's in here somewhere. It is it's volcanic rocks, intermediate to mafic, and they've been metamorphosed to not metamorphosed. They've been medium grade low grade to medium grade metamorphosed. So there's some schist in places. So we will be in that area. So, but that made me think, where are the actual oldest rocks in Ontario? And I still can't answer that question, because they're probably somewhere really up north, up further than we're going to go. But as far as I know, that is the oldest directly dated age we have. I'm talking about in Ontario, not Canada, just within Ontario. But anyway, if you know of an older one in Ontario, please let me know. Link it below, because I've been unable to find it. But anyway, that's it. If this is going on 14 minutes, if you have any questions or comments, please leave them below, and I hope you learned something.